Hello all and welcome back. Tables in Excel is one of the most powerful yet underutilized feature. And the reason why I say underutilized is because many people think that coloring cells, creating borders around the cells makes it a table. No, that's not what a table is. A table usually consists of a row header, rows, columns, totals row, and so many other things. In fact, it's the most efficient way to organize your data in a meaningful way. It can store so many kinds of data, for example, employee data, sales data, appointments, and so many other things. It is also known as a list object in VBA, and that is because it has replaced the list functionality which was present way back in Excel 2003. So in this video, not only we will learn how to create a table, but we will also learn how to interact with it, resize a table, insert rows, columns, and so many other things. So let's begin. I'm going to use this raw data to demonstrate how to work with tables. If you notice, I have two worksheets here. Both sheets contain the same data. We will not work with the first sheet, which is raw data. We will work with the second sheet, which is working sheet. So if I go there, you'll see that it contains the same data. During this video, we will try to convert this raw data to a table which should look something like this. Okay, before we begin, let's first visually understand the structure of a table. This object is a table. It is also referred to as list object in VBA. This is the range, which is the whole area of the table. This is the header row range. It is the top row of the table containing the column headers. This is the totals row range. You may choose to display it if you want. Otherwise, by default, this is hidden. It includes calculation that you want to perform using subtotal. I will not go too much into subtotal in this video. In fact, I will cover subtotals much more in detail in the next video. The section between the header row and the totals row is called the data body range. This is the list row. So each row is a list row. And this is a list column. Each column is a list column. We will work with all these objects in details. So let's launch the Visual Basic Editor by pressing the shortcut key Alt F11. If you're not sure what Visual Basic Editor is, then I recommend watching the video Visual Basic Editor and Introduction. Here I have code in few modules which we will use to work with the table in details. Let's open the first module. You can either double click on this or you can right click on it and click on View Code. Here I have a procedure called Create Table. In this procedure, we will create a table using ListObjects.Add method. Let's understand the syntax of ListObjects.Add. The syntax is expression.add source type, source, link source, Excel list object has headers, destination, table style name. Expression is a variable that represents a list objects object. The list objects is a collection of all the list objects in a worksheet. Each list object represents a table in a worksheet. All the parameters, be it the source type, source, link source, and others are optional parameters. The source type indicates the kind of source for the query. It can be one of the following Excel list objects source type constants: Excel SRC external, Excel SRC model, Excel SRC query, and so on. The source depends on what you choose for source type. When source type is Excel SRC external, then source is an array of string values specifying a connection to the source containing the following elements: URL, list name, and view GUID. When source type is equal to Excel SRC query, the source accepts ODBC or OLEDB connection string. When source type is Excel SRC model, the source accepts a workbook connection object. When source type is Excel SRC range, then the source is a range object representing the data source. And if you omit this, the source will default to the range returned by list range detection code. In this video, we will work with Excel src range as source type, which will take the range from this workbook as source. The linked source indicates whether an external data source is to be linked to the ListObject object. If source type is Excel src external, the default is true. Linked source parameter cannot be used when the source type is Excel src range. Excel list object has headers is an Excel yes/no guess constant, which can have three values: Excel guess, Excel no, or Excel yes. When Excel list object has headers is Excel guess, then Excel determines whether there is a header and where it is, if there is one. When Excel list object has headers is Excel no, then the entire range is taken into account and Excel will automatically generate headers. When Excel list object has headers is Excel yes, then Excel picks the first row as header. The default value of Excel list object has headers is Excel guess. Destination is a range object specifying a single cell reference as the destination for the top left corner for the table. If the range object refers to more than one cell, an error is generated. The destination argument must be specified when source type is set to Excel src external. When source type is set to Excel src range, the destination argument is ignored. So feel free to specify it if required. The destination range must be on the worksheet that contains the list object collection specified by expression. New columns will be inserted as the destination to fit the new list. Therefore, existing data will not be overwritten. Table style name is the name of a table style. For example, table style medium 2. Later in this video, I will show you a neat trick on how to find the name of a particular table style. For the time being, while creating a table, we will use table style medium 2, which is this style. So let's go back and let's understand what the code is doing. Here I have declared variables for my worksheet, last row and range. Here I have declared a variable for my table, which is a list object. And here I am initializing the WS data object to sheet 2. Let's go to sheet 2 for a moment. Here I have a small data set, let's say for the employees of a company called Team Excel. We have names, email, phone number, date of hire, etc. We will convert this range into a table. So let's go back. Here I am finding the last row in column A. Finally, I am identifying the range that will be converted to a table. Here I am creating a table using .ListObjects.Add. My source type is Excel src range, and I have set my source as the range RNG. I'm also telling VBA that my data has header. The table style that I'm using is table style medium 1. Let's run this code and see if we get the desired result. To run the code, click on the Run Sub-User Form button or simply press the shortcut key F5. Let's go to the worksheet. The raw data is now converted to a table using table style medium 1. Now you may not like this table style and may be curious as to which all table styles are available and if you could use them. Let me share a nice trick on how to decide and find the name of a particular table style. Click anywhere inside a table if any other cell outside the table is selected. Currently A1 is selected, so that's okay. When the selection is inside a table, you will have access to a new tab called Table Designs. So if I select outside the table, that tab will not be visible to you. So if you click anywhere inside the table, you can see that tab reappear. Currently that tab is selected. If that tab is not selected, then click on that tab. Here you can see a section for table styles. If you click on this drop down, you can see the style has been divided in 3 sections: light, medium and dark. And if you do not like any style, then you can create your own by clicking on new table style. Let's say you like this one, which is white table style medium 1. Now, how do I know what is the name of this style? You can quickly find that by recording a macro. If you're unsure how to record a macro, then see the video how to record, edit and run a macro in Microsoft Excel 365 for Windows. So let's click on the Developer tab and click on Record Macro. Let's click on OK. We will now head back to the table design and then I'll click on this drop down and then I'll select different styles. So I'll select this first. Next, I'm going to go back here. I'm going to select this, then this, and let's say I select this. I did this because we are recording. And as I mentioned in the video how to record, edit and run a macro in Microsoft Excel 365 for Windows, Excel is recording my every action. Well, almost every action. So that is the reason why I clicked on several styles. Now let's stop the macro. And let's go back to the VBA editor and see what the VBA code recorded for us. Here we see that we have the table style names of all the style that we clicked. So now let's go and try a new style, which is table style medium 2. So I'm going to copy this. Let's go to create table and I'm going to change this to table style medium 2. Before I run this code, what I'm going to do is I'm going to sheet 2. I'm going to delete all the data from here and then I'm going to copy this data and paste it again. I'm going to do this couple of times manually. Later in the video, I will show you how to convert your table back to its original state. So now let's go back and let's run this code. If you go back to the worksheet, you will notice that the table has a new table style now. Earlier it was black and white, now it's blue and white. Moving on to the next section, which is converting a table back to range. So let's go to module 2. Here I'm initializing the myTable object to the first list object in the worksheet. Since there is only one table, I'm using 1. If there were multiple tables, then I would have used the table name. To find the table name, go to the worksheet and in the name box, you can get the table name here. You can also get the name of the table from the name manager in the formulas tab. I've spoken about the name manager in the video named ranges in Microsoft Excel. So if we click on name manager and if we click on this filter, I will get a couple of options. You can use the table names to filter the named ranges. So if you click on table names, you will get all the names of the table in this list. Currently there's only one name, so obviously it will not make any difference. But in case there are a lot of names here, you can actually filter the list on the table name. So the name of my table is table 1. So I can actually go back and I can change this one to table 1. Moving on to the next line of code. Here I'm using the ListObject.Unlist method. This method removes the list functionality from a ListObject object. After you use this method, the range of cells that made up the list will be a regular range of data. So let's run this and let's see what happens. If you look at the data, this is no longer a table, it's just a simple range. However, we see that the formatting is left intact. So what we will have to do is we will have to remove the table style before we convert the table back to range. So what I'm going to do is I'm going to repeat the process. I'm going to delete this. I'll go to raw data, copy this data and I will paste it here again. Next I will go to module 1 and I will run this code. And we have a table here. Notice the name of the table now is table 2. Now let's go back to module 2. Here I'm going to change the name of the table to table 2 and I'm going to uncomment this line. What this line will do is it will remove the existing table style and then when the next line is run, which is myTable.Unlist, it will change the table back to a normal range with no formatting. So let's run this. If you go back to the worksheet, you will notice that the table has been changed to a normal range with no table style. Okay, moving on. The next thing that we will cover is how to check if the worksheet has any table. And we will also check if the worksheet has a table with a specific name. So let's go to module 3. Here I am displaying the count of list objects in my worksheet. This will show me the total count of tables. So if the value is greater than 0, then it means that there is at least one table in the worksheet. Let's run this. And I get 0. That is because the VBA code was not able to find any table in this worksheet. Let's click on OK. Now I'm going to go and create a table. Let's go to the worksheet and we see that a new table has been created, which is table 3. So if I go back to the code and now if I rerun that code, let's see what do we get. This time I get 1. So the VBA code was able to find one table in this worksheet. Moving on, let me comment this. Till now, what we were doing was we were manually trying to find the name of the table. Now I will show you how to find the name of the table using VBA. To get the name of the table, you can use the ListObjects.Name property. This is a read-write property. That means you can use it to not only get the name of the table, but you can also use this to name a table. We will cover that in a short while. So let's run this. And I get the name as table 3. So I can use ListObject.Name property to get the name of the table. Let me comment this now. Moving on to the next section. Now let's check if there is a table with a specific name in the worksheet. Here I have a variable which has the name of the table that we want to check if it exists. And here I have a function which will return true or false based on whether it was able to find the table or not. If you're unsure how procedure and functions work, then I highly recommend watching the video What are sub-procedures and function procedures in Microsoft Excel for Windows. Here I have a variable for my list object, and here I am looping through all list objects in the worksheet and checking if any of the table matches the name that we passed to this function. So let's run this. And we get false. That is because there is no table with the name employees. Now let's change the name of the table to table 3 because that is the name of our table. Yeah, so this is table 3. So let's go back and I'm going to make this table 3. Now if I run this, it gives me true. That is because it found a table with the name table 3. Okay, the next thing, if you noticed here, we are working with a for loop. If you're not sure how loops work in Excel, then do watch the video Understanding 5 Loops in Microsoft Excel 365 for Windows. Below this code, you notice this uncommented code. That is an alternate method to this loop to check if there is a table with that name. So let's test it. I'm going to comment the for loop and I'm going to uncomment this section. Here what I'm doing is I'm attempting to initialize the list object variable using the name that we want to check. What will happen here is if a table with the name exists, then this variable will get initialized. But if there is no table with that name, then this line will throw an error. So to prevent or rather suppress that error, what I'm doing is I'm sandwiching this line between on error resume next and on error go to 0. So what this will do is if there is an error, then it will suppress the error message and it will continue executing the rest of the code. Here I'm checking if the variable was initialized. If a table with the name exists, then this variable will be initialized, else it will be nothing. Okay, so let's run this. And I get true. So this works. So we saw 3 things here. First is how to get the total tables count in the worksheet. Second, how to get the name of the table. And the third, how to check if there is a table with a particular name. Moving on, the next section that we will cover is how to name a table that we will create. So let's run the code from module 2 to reset our data. Here I'll change the table 2 to table 3 because that's the name we have. I've run this. Let's go back. Yes, the table has been converted to a normal range. Now let's go to module 4. The syntax to add a name is expression.name. Like I mentioned earlier, it's a read-write property. So you can use this to assign a name to the table that you created. Let's understand what the code is doing here. Most of the code is the same code that we have in module 1. The only thing that we have here is this variable which has the name of the table that we want to create. Here I'm checking if there is already a table with the name employees. And if there is, then I am alerting the user and then exiting the process. Here I'm naming the new table. The rest of the code, like I said, is the same as in module 1. So let's run this. If you go to the worksheet, you will see that we have a table and the name of the table is employees. Now let's go back and let's try to run the same code again. Notice what happens when I run this code again. It says there's already a name with employees, choose a different name. And the code exits gracefully. That is because of this particular section of the code. So let's try and change the name of the table. What I will do is I'll make this employee data. Now notice what happens when I run this code. I get a different error, which is a table cannot overlap another table. We are getting this error because there is already a table in that range and you cannot create another table on top of that table. If you click on debug, it will highlight this line. So how do we handle this? There are two options that we have. First, we alert the user and then exit the code gracefully. Currently the code is breaking on this line. So when we handle that, it will not break on this line and like I mentioned, it will exit the code gracefully. Second, what we can do is we can use unlist on the table object which is using that range. This way the table will be converted to a normal range and then we can create a new table on that range. Let's do one thing. Let's first stop this code and let's handle option 1 first. I'm going to use option A procedure for this, which is here. Let's understand what this code is doing. Here I have defined an extra variable for my list object. Here what I'm doing is I'm looping through every table and checking if the range of that table intersects with the range where we are trying to create a table. And if it does, then we are alerting the user and then exiting the code gracefully. The rest of the code remains the same. So let's run this. And we get the relevant alert and the code will exit gracefully the moment I click on OK. See, it did not break on that line. Now let's handle option B, where we will use unlist on the table object to convert it to a normal range. And then we will create a new table. I'm going to use option B procedure for this, which is right here. Let's understand what the code is doing. This code is the same as option A, except instead of using employee data, I'm using employees as there's already a table with that name. So if you go back to the worksheet, you will see that's the name of the table. Let's go back. And here, instead of showing a message and exiting the sub, I'm unlisting it and then exiting the for loop so that the rest of the code can run. Now let's run this and let's see what happens. And I get the message, which is there is already a name with employees, choose a different name. So this section works. Now I'm going to remove the S and I'll make it employee so that this section is not executed and the rest of the code goes ahead. Now let's run this. And this time I do not get any kind of message. So if you go back to the worksheet, you will notice that the new table has been created and the name of that table is employee. Moving on. Now that we have our table, let's add some table style options For example, totals row, let's also highlight first column, last column. We will also try and tweak other properties like banded rows, banded columns and other options. Let's go to module 5. The first property that we will cover is ListObject.ShowTotals property. This property gets or sets a boolean to indicate whether the total row is visible. Here we are setting the ShowTotals property to true. When we run this code, the totals row will appear right at the bottom of the table. So if I go back to the worksheet and if I scroll down, you'll notice there's nothing in row 22. When I run that code, there will be a totals row here. So let's go back. Let's run this code. If you go back to the worksheet, now you will see that you have a totals row in row 22. The totals row includes calculations. You can choose what kind of calculation you would like to display in the table. It can be sum, minimum, etc. So if I click on this and if I click on this drop down, you will see Excel gives you options that you can choose. You can display average, you can display count, you can display max, standard deviation, etc. The next property that we will try to understand is ListObject.ShowTableStyleRowStripes. This property returns or sets if the row stripe table style is used for the specified list object. Currently, if you look at the table, it has banded rows. If you wish, you can remove this by setting this property to false. So if you go back to the code, I'll comment this line and I'll uncomment this. So if I set this to false and if I run this, and if you go back to the worksheet, you will notice that the table does not have any banded rows. So let's set it back to true because it looks really nice with banded rows. So I'll change this to true and I'm going to run this again. So if you go back, you'll see that the banded rows are back in the table. Just like you can enable banded rows, you can also enable or disable banded columns. The property for that is ListObject.ShowTableStyleColumnStripes. This property returns or sets if the column stripe table style is used for the specified ListObject object. Currently, the table doesn't have banded columns. If you wish, you can apply this by setting the property to true. Just for testing purpose, let's set it to true and then we will set it to false because I really don't like banded columns in my table. So what I'm going to do is I'm going to comment these two lines and I'm going to uncomment this and I'll change this to true. Let's run this. If you go to the worksheet, you will see that the table now has banded columns. It looks pretty weird. This is the reason why I usually keep it off. So I'll go back, I'll change this to false and then I'm going to run it again. And the banded columns have disappeared. The next property that we will tweak is ListObject.ShowHeaders. This property returns or sets if the header information should be displayed for the specified ListObject object. So if you set this property to false, it will hide the headers. Currently headers are displayed. Since we want the headers, we will not set this property to false. But just to demonstrate, let's do that and then we will reverse the changes. So I'm going to comment this and I'm going to uncomment the next line and I'll change this to false. If I run this, you will notice that the headers have disappeared. Obviously we want headers, so I'm going to set it to true again. And let's run this. And there you go, we have our headers back. If you notice, our headers have filters. So that's the next property that we will tweak. By default, the headers will have filters. If you do not want to show the filters, then you can set it to false by setting the property ListObject.ShowAutoFilterDropDown to false. Let's test it. I'll comment this and I'm going to uncomment the next line. I'll make this false. I'm going to run this If you go back, now you will notice that the headers do not have any filters. I usually like keeping my filters because I like my clients to be able to filter on different values. So let's go back. I'm going to change this to true. And we have our filters back. The next property that we will tweak is ListObject.ShowTableStyleFirstColumn. This returns or sets if the first column is formatted for the specified ListObject object. So we will first set it to true and let's see what happens. So this is currently how my table looks like. The first column, look at the font, it's not bold. Okay. So now what I'll do is I'll go back to the code, I'll comment this and I'll uncomment this. Now if I run this, see what happened to the first column. The font is bold. You can achieve the same thing with the last column using the ListObject.ShowTableStyleLastColumn property. This property returns or sets if the last column is displayed for the specified ListObject object. Look at the last column. Now let's go back and we will uncomment this. Let's run this. There you go. Even the last column now has bold fonts. All these properties that we tweaked are the same properties that you can access in the table style options group in the table design. So if you go here, these are the options that we just tweaked. Now let's try and read different values from the table. As I mentioned earlier, this is the header row range, this is the totals row range, this is the data body range, this is the list row, and this is a list column. So let's first interact with the header row. To work with the header row, we can use the ListObject.HeaderRowRange property. This property returns a range object that represents the range of the header row for a list. Let's go to module 6. Here I have initialized my table to existing table employees. Here I have declared a range which will hold my header row range, and here I am initializing it. Here I am getting the address of that range so that we can visually see the address of the header row range. And in this section, I am accessing the individual headers by simply using header row parenthesis followed by the column number. So here the code will return the value from the 7th column in that range. Let's run this. The address that I get is A1 to J1. So my header row range is from A1 to J1. If I click on this, I get designation, which is the value of the 7th column. Let's click on OK. Similarly, if I want to, let's say, get the value from the 3rd column, all I have to do is change this to 3. And if I run this now, I get the address, okay, and I get the value last name from the 3rd column. Just like we worked with the header row, we can also work with the totals row. Let's check out the procedure accessing total row. To work with the total row, we can use the ListObject.TotalsRowRange property. This returns a range object representing the total row, if any, from a specified ListObject object. So this code is similar to what we had above. Here I have declared a variable RNG totals row as range, and I'm initializing it to the totals row range. Here I am displaying the address, and then I'm trying to pick up the value from the 10th column in the totals row. So let's run this. This time I get A22 to J22, which is this row. If I click on OK, see what do I get? I get 2.09, which is 209%. Let's click on OK. The next property that we will cover is ListObject.DataBodyRange. This property returns a range object that represents the range of values excluding the header row and the totals row in a table. To access individual values, simply use DataBodyRange parenthesis followed by the row number and the column number. So let's check out the procedure accessing DataBodyRange, which is right here. This procedure is also similar to the above procedures. Here I have a variable RNG data body and I'm initializing it to myTable.DataBodyRange. Here I'm trying to get the address of that range, and finally I'm trying to extract the value from that range from row 5 and column 2. So let's run this. I get A2 to J21, which is this range minus the header row and the totals row. When I click on OK, I get Brenda. This is from the 5th row, 2nd column. Let's go back. The next property that we will cover is ListObject.ListRows. This property returns a ListRows object that represents all the rows of data in the ListObject object. To access individual values, simply use ListRows parenthesis followed by the column number. Let's check out the procedure accessing ListRowRange. Here I have the RNG ListRow variable which I am initializing to the 5th row range. Here I am displaying the address, and then I am trying to extract the value from the first column in that row. Let's run this. And we get A6 to J6, which is the 5th row in the data body range. And when I click on OK, I should get 100005, which is the value from the first column of that row. See, let's go back. Just like we used ListObject.ListRows to access the rows, you can use the ListObject.ListColumns property. This property returns a list columns collection that represents all the columns in a ListObject object. Let's check out the procedure accessing ListColumnRange, which is right at the bottom. Let me add few blank lines so this comes right at the top. It will be easier to read the code. Here, you can either use the column number or the column name. Okay, an interesting thing. If you use .range with list columns, then you will refer to the entire column including the header row and the total column. And if you want to work with the range excluding the header row and totals row, then use .DataBodyRange. Let's test both of them. So first let's test the DataBodyRange. Here I'm displaying the address, and here I'm picking the first value in that column. So let's run this. I get A2 to A21. So this excludes the header and the totals row. Let's click on OK. And I get the first value, which is 100001. Now let's comment this and let's uncomment this. When I run this code, it includes the header and the totals row. And now when I click on OK, instead of showing me 100001, it will show me employee ID. See? So remember two things when you're working with the columns. You can either pass the column number or you can pass the column name. Second, if you want to work with the range which does not include the header and the totals row, then use .DataBodyRange. And in case you want to include the header and the totals row, then simply use .range. Now let's try and add some rows and columns to the table. Let's view the code in module 7. We will work with the rows first. To add a row, we have to use ListRows.Add method. The syntax is expression.add position always insert. Expression is a variable that represents a ListRows object. Position is optional. It specifies the relative position of the new row. Always insert is also optional. It's a Boolean value that specifies whether to always shift data in cells below the last row of the table when the new row is inserted, regardless if the row below the table is empty. If set to true, the cells below the table will be shifted down one row. And if set to false, if the row below the table is empty, the table will expand to occupy that row without shifting cells below it. But if the row below the table contains data, those cells will be shifted down when the new row is inserted. Let's check out the first procedure, adding deleting rows to table. Here I have declared the variables and initialized my table. And here I am adding a row. Since I'm not specifying any row position, the row will be added at the end. So let's run this and let's check it. If you go to the worksheet, you will see that a row has been inserted in row 19 of the worksheet, which is just above the totals row. Now, if I want to add the row at, let's say, the 4th position, then we can also do that. So if you go back to the code, I'm going to comment this and I'm going to uncomment this. Here I have mentioned the position as 4. So when I run this code, one row will be added at the 4th position. So if you go back, you will see a row has been added at the 4th position. Let's go back and let's comment this. Now let's learn how to delete a row. Deleting a row is as easy as you add it. To delete a row, simply use the ListRow.delete method. This method deletes the cells of the list row and shifts upward any remaining cells below the deleted row. The syntax is expression.delete. Let's delete the row we just added at the 4th position. So what I will do is I will uncomment this line. So I'm going to run this, and if you go back, you will notice the row which was here is gone. So we saw how we can delete one row. Now let's try and delete multiple rows. To delete multiple rows, we have to use range.rowsDelete method. Simply mention the range that you want to delete. So let's go back, and this time I'm going to uncomment the last line. Here I am specifying that rows 6 to 8 should be deleted. If I run this code, then these lines will be deleted. Let's go back and let's check. So let's run this, and the VBA code deleted those lines. So let's go back. Just like you can add rows, you can also add columns to the table by using ListColumns.Add method. The syntax is expression.add position. Expression is a variable that represents a list columns object. Position is an optional variable. It specifies the relative position of the new column that starts at 1. The previous column at this position is shifted outward. If position is not specified, a new rightmost column is added and a name is automatically assigned to it. The name of the new column can be changed after the column is added. So let's check out the procedure adding deleting columns to table. Here I have declared the variables and initialized the table. Here I am adding a column just like I added rows above. So I'm going to run this. If you go to the worksheet, you will notice that one column has been added at the end. And if I expand this, the VBA code named it as column 1. Let's go back. Just like we added a column at the end, we can also add a column at a specific position. So if I comment this code and I uncomment this line. So here I am trying to add a column at the 4th position. Let's run this. And a column has been added. Let me make this a small column. This happened because it copied the formatting from column E, and column E was already this big. Okay, let's go back. Now let's see how we can delete a column. Deleting columns is similar to deleting the rows. You can specify a position, or you can also mention the name of the column. The syntax is expression.delete. Expression represents a list column object. This method deletes the column of data in the list. So I'm going to comment this. Let's try and delete the first column. So if you go back, the first column is employee ID. This column will be deleted when we run this code. See, it's gone. Now let's try and delete a column by giving the column name. Here the column name is first name, last name, column 2, email, etc. Let's try and delete the first name column. So I'm going to comment this line and I'm going to uncomment this line. When I run this, that column is also deleted. So remember, when you're deleting columns, again you can specify either a column number or a column name. Okay, moving on. Now let's see how we can sort a table. But first, let's copy the data from sheet 1 and let's recreate the table. So I'll delete this, I'll go to the raw data, I'll copy the data and I'll paste it here again. Next, I'll go to module 4 and I will recreate the table. Let's go back. Yes, the table has been created. Great. Now let's move on to module 8. Here I have declared the variables and initialized my table. And here I'm using the table.sort method which will sort the table. Here I'm using sortFields.clear method which clears all the sortFields object if there are any. And here I'm using the sortFields.Add method to create a new sort field which will return a sortFields object. The syntax of sortFields method is expression.add key sort on order custom order data option. Key is the required range. It specifies the key value for the sort. Sort on is optional. It is the field to sort on. The order is also optional. It specifies the sort order. Custom order is optional. It specifies if a custom sort order should be used. And data option, which is also optional, specifies the data option. So in this code, I have specified the key as first name range. I'm sorting on values and here I'm specifying that the sorting has to be in ascending order. And here I'm specifying the data option property as Excel sort normal, which means we want to sort numeric and text data separately. This is the default value of this property. You can ignore mentioning this if you want. The other value this property can have is Excel sort text as numbers, which means that we want to treat text as numeric data for the sort. And here I'm telling VBA that my data has headers. Finally, I'm applying the sort. So let's go ahead and let's run this. If we go to the worksheet, we see that the first name column has been sorted in an ascending order. So here we sorted on one column. What if we wanted to sort multiple columns? So let's go back and check out the second procedure, which is here. All you have to do for this to work is to create a new sortFields object using sortFields.Add as shown here. Here I am now sorting on the second field as well, which is last name. Now, when you run this, you may or may not see the difference. So, to see a clear difference, let's change Alan to Aaron. So I'm going to copy this and I'm going to paste it here. The reason why I did this is because the last name of Aaron is Cooper and for this Aaron it is Alan. So when I sort it on the second level, which is on last name, then Aaron Allen should go above Aaron Cooper. Okay, let's test this. Now I run this code again. And if you go back, see how Alan Cooper moved below Aaron Allen? So this is how you can sort the column or columns in a table. You can specify one level or you can specify multiple levels for sorting the data. Moving on to the last topic. Now let's see how we can resize a table. You can shrink or expand a table by using the ListObject.resize method. This method allows a ListObject object to be resized over a new range. No cells are inserted or moved. The syntax is expression.resizeRange. Expression returns a ListObject object. The range is a required parameter, which is the new range. So let's go to module 9 to understand how this works. So this part remains unchanged. Here I'm trying to shrink the table's range. Currently the table is from A1 to J21. Let's shrink it to, let's say, A1 to J15. So let's go back and let's run this code. If you go back to the worksheet, you will see that the table range is now from A1 to J15, and the rest of the 6 rows are no longer a part of this table. Just like you shrank the table, you can also expand the table using the same method. So I'm going to go back to the code. I will comment this and I will uncomment this. So here what I'm doing is I'm expanding the row back to its original range, which is A1 to J21. So when I run this, now you'll see that the table includes the other 6 rows as well. If you go back to the code, you will see that I'm using hard-coded ranges. If you wish, you can also pass a dynamic range to ListObject.resize method. So let's comment this and I'm going to uncomment these 3 lines. Here what I'm doing is I'm using the range.resize property to create a dynamic range. Here I have declared a RNG variable for my range object. And here what I'm doing is I'm using the range.resize property to create a dynamic range. This property resizes the current specified range and then returns a range object that represents the resized range. The syntax is expression.resize row size, column size. The row size is an optional parameter. It is the number of rows in the new range. If this argument is omitted, the number of rows in the range remains the same. Column size is also optional. It is the number of columns in the new range. If this argument is omitted, the number of columns in the range remains the same. So here, what I'm doing is I'm creating a dynamic range which has the same range of the table range plus 10 extra rows and 5 extra columns. And then I'm passing this dynamic range to the ListObject.resize method. So let's run this and let's see what happens. If you go to the worksheet, you will notice that now the table has 10 extra rows, and if you go towards the right, it has 5 different extra columns. So if I autofit this, you will see these are 5 columns. Working with tables is super easy and it is really fun if you have a good understanding of the list object. Time for a quick recap. In this video, not only did we learn how to create tables, but we also learned how to interact with different components of a table. Whether it was the header row range or the rows, the columns, the totals row, and so many other things. We learned how to add columns or rows at the end of the table. We also learned how to resize a table, how to check if a worksheet has a table or whether a worksheet has a table with a specific name, and so many other things. So I hope this video was easy to understand, but if you still have any questions, please feel free to leave a comment in the comment section below. Or you can also email me on support@tamexcel.com. I also have a Facebook page. The link is in the description below. Feel free to join that. If you have any questions, please post it there. I'll be more than happy to answer your queries. If you would like to extend support towards this channel, if you think that I am putting some good content, then go ahead, watch a couple of videos, drop a couple of likes. And if you're really serious about learning Visual Basic Programming from scratch, then go ahead and watch the playlist, because that is where I have kept the videos in a specific sequence which will really help you learn Visual Basic Programming from scratch. And if you still have not subscribed to this channel, then go ahead and subscribe to this channel by clicking on the bell icon. And then in the next video, I'll talk to you about one more powerful yet underutilized feature of Microsoft Excel, which is subtotals.